Hi everyone, it's Coach Fred and I'm back with part 2 of decomposing or partial fraction decomposition. And today I'm going to be looking at second example, example 2, when the denominator is a product of linear factors, some of which are repeated. Okay, so yesterday we talked about the process of taking a rational function or rational expression and breaking it into parts using the process of partial fraction decomposition. So let's review that process. We're going to take, number 1, the degree of the numerator has to be less than the degree of the denominator, which in this case it is. So I'm going to write an equation, and I'm going to break the equation up by factors. Now this one's slightly different because you can see we have a factor of x, okay? But we also have to consider every factor of x minus 3. So we have a factor of just x minus 3, and we also have a factor of x minus 3 squared. So we have to use both the factor x minus 3 and the factor x minus 3 squared. And remember, we're looking for the constants. So the constant a, b, and c. Okay, so now this is where we, like yesterday, we cleared the fractions to help us here, okay? So if I clear the fractions, I'm going to multiply the entire equation by x times x minus 3 squared. Okay, every single term gets multiplied by that. So on the left side, we're going to be left with x minus 18. With the first term, we're going to be left with a times x minus 3 squared. In the second term, we're going to be left with bx times x minus 3. And in the last term, oops, I forgot the plus there, we would be left with cx. Okay, so now we have to actually do some algebra here. So the first thing we need to do is to multiply the binomial square here. So if we remember the square of a binomial, it will multiply to a perfect square trinomial. So I'm going to put that pattern in, which would be x squared minus 6x plus 9. Plus, I'm going to distribute my bx here, and I'm going to get bx squared minus 3bx, and then plus cx. Okay, so now I want to make sure I still have to distribute that a through each term. So I have x minus 18 equals ax squared minus 6ax plus 9a plus bx squared minus 3bx plus cx. Now take a look at that. That's actually kind of messy, right? And we want to make sure that, that we collect the like terms very, very carefully here, okay? So when I collect these like terms, just think about very carefully what you're trying to do with each of your factors, okay? All right, so my like terms over on this right side are going to be, let's see, I've got, ax squared and a bx squared. They're like terms. I'm actually going to do this to kind of help you guys see that. I used that and I used that. Now I have this x, and this x. Now I'm going to write that a little bit differently. I'm going to write that as, all right, so I'm going to put them all together. I'm going to put, okay, so minus 6ax minus 3bx plus cx. So I'm going to get rid of that, and that. And now I still have this 9a. Remember, that actually is a constant because a is a constant and 9 is a constant. All right. So now we want to get the left looking like the right. Remember, equals means is the same as. So here I'm going to actually, I noticed that I can't really get the left to look like the right because this doesn't have an x squared term. So if you remember back when you used to do long division and synthetic division, you had to actually put a placeholder for any terms that weren't considered. So I'm actually going to rewrite the left side as 0x squared plus x minus 18. So now I have a trinomial on the left because it looks like this is going to work out to be an x squared, an x, and a constant, so a trinomial on the right. All right, so what am I going to do? I'm going to factor out the x squared, and that's going to leave me with a plus b x squared. And over here, I'm actually just going to write plus, and I'm going to rewrite this. I'm going to factor out the x, and I'm going to be left with 6a minus 3b plus cx plus 9a. Okay? Now remember, equals means is the same as. Now by putting this 0x squared term in, now I can see that a plus b will equal 0. Remember, we're trying to write a system of equations. And then I can see that there's a 1 here. So negative 6a minus 3b plus c is going to be equal to 1. And then 9a is going to be equal to negative 18. Okay, so hopefully you saw how I came up with the system of equations. Now I'm going to solve the system. Luckily, this one's really nice because I have this term here. I'm just going to solve for a. So if 9a equals negative 18, then a equals negative 2. All right, I'm going to plug that into that equation. So negative 2 plus b equals 0, so b equals 2. That's helpful. I have my a, I have my b, and now I'm going to use that to find my c. So negative 6 times negative 2 is 12, minus 6 plus c equals 1. So 12 minus 6 is 6. 6 plus c equals 1. I'm going to subtract 6, and so c equals negative 5. So I have the 3 constants that I needed, so I'm ready to put that into my composition. Remember, a broken down rational expression. All right, so my a was 2, so 2 over x. My b was 2 as well. Sorry, my a was negative 2. My b was 2. Make sure that's right. Yep, a was negative 2, b was 2. So 2 is going to go over that second factor of x minus 3. And then we have negative 5 over x minus 3 squared. Now, that doesn't look so pretty because I got the negative here and the negative here. Let's clean that up a little bit. So we can rewrite this as 2 over x, so negative, we can pull that out to the front, plus 2 over x minus 3 minus 5 over x minus 3 squared. And that is my partial fraction decomposition of that original rational expression way up there, x minus 18 over x times x minus 3 squared. All right, guys, so that was kind of like the algorithm to how you do it when you have different linear factors. Hopefully that was helpful, and you will be going on to video number 3. Have a great day.